Hello friends, this is SK Booty here, back with you for the next lesson on navigation numericals. And today's topic is shape of the earth and various numericals connected with the change of latitude, longitude, etc., etc. Now, let us first have a brief background about the earth. Earth is an oblate spheroid, and its polar diameter is less than the equatorial diameter. Small difference, but there is a difference. For the practical purposes, we consider the Earth to be a perfect sphere, and that is what we will be working on. To identify places on the Earth, we have a system of latitude and longitude. You have to keep reporting your position to the ground and exchange it between the aircraft. And the universal method is latitude and longitude of a place over which you are flying. Next is we have created a network of vertical circles and horizontal circles on the surface of the Earth. The circle whose center and radius is same as that of the Earth is called great circle, and all other circles are called small circles. This total network, imaginary lines drawn on the surface of the Earth, this total network is called graticule, Graticule. Okay. Now, what is this network? There are vertical circles joining the North Pole with the South Pole. Half of the great circle will be on your side, other half will be on the other side of the Earth. And these semi-great circles are called meridians. The other meridian 180 degrees away from you will be called your antimeridian, and meridian and antimeridian combined will be a great circle. These meridians are numbered from a meridian which is called prime meridian or the Greenwich meridian, numbered towards east and west 180 degrees each. 180 degrees east or 180 degrees west will be the anti-meridian of the Greenwich meridian. Suitably modified, it is also called international date line. Fine. So meridians are numbered towards east or west in degrees, minutes, and where required, it can be further in seconds also, if minute details of that area or map are required. In aviation, we work generally up to degrees and minutes. Then a great circle dividing the Earth in two equal halves called the northern hemisphere, and the southern hemisphere is called equator. Parallel to equator are the small circles, 90 degrees to the north, 90 degrees to the south. And these parallels of latitude are small circles, except 90 degrees parallel of latitude, which is a point called North Pole, and the other end is called South Pole. So that's the general shape of the Earth. I hope you have this diagram with you, or draw this diagram with you, and then start doing these numericals, which we are going to do today. Now, let me free up some space. There you are. Okay, let me delete this circle also. Next, on a slightly bigger diagram now, we will do the numericals. North of equator, at each degree interval, there is a parallel of latitude, and each degree is then divided in minutes. Place A, as you can see, is north of equator, and place C is south of equator. Place X is east of the prime meridian, and place F is west of the prime meridian. Let us first understand what is dlat or shlat, difference in latitude or change of longitude between two places. And let us say we have taken this place A and B at the moment. Read the latitude of both in degrees and minutes and find out the difference. They are both in the northern hemisphere. From A to B, your change of latitude will be north, and B to A, change of latitude will be south. B to A, you are in the northern hemisphere, but you are going southwards. So change of latitude will be south. Between A and C, to find out the change of latitude, add the latitude of A from equator and a latitude of C from equator. If this is 15 degrees north and this is 35 degrees south, then total change of latitude will be 50 degrees. If it is 15 degrees 20 minutes, 35 degrees 10 minutes, then add 15 degrees 20 plus 35 to 10, and that will be your change of latitude. Has to be added in degrees and minutes. Now, from B to C, again, add the latitude of B from equator to the latitude of C from equator and add them up. That will give you the change of latitude between B and C or A and C. And if your destination is in the southern hemisphere, change of latitude is south. If you are measuring from C to A, destination is in the northern hemisphere, change of latitude will be north. Right. Now, between A and this point X, which are on the same parallel of latitude, there is a change of longitude. A is on 20 degrees east. So 20 degrees east, your change of longitude. D is 40 degrees east. So between A to D, change of longitude will be 40 degrees east. And between X and D, it will be 20 degrees east, the difference. And between X and D, since D is further east, change of longitude is east. But between D to X, change of longitude will be west. You are both the places of east of prime meridian, but X is less east compared to D. So we will say we are traveling, change of longitude is west. Between D to F, the change of longitude will be longitude of D from prime meridian plus longitude of F. Add them up since they are in the different hemispheres. If F is 50 degrees west and D is 40 degrees east, then total change of longitude between these two places will be 90 degrees. If your destination is east, F to D change of longitude is in east, and if your destination is towards west, then the change of longitude will be west. This is how we find out the change of latitude and longitude. Change of latitude is between two places on the same meridian. There will be only change of latitude, no change of longitude. If two places are on the same parallel of latitude, then there will only be a change of longitude. There will be no change of latitude. Now let's say there is a place G here it is, which is north of equator and east of prime meridian. Between A and G or G and A, there will be a change of latitude as well as longitude. Change of latitude will be here, A to B, and B to G is the change of longitude. So between A and G, there will be a change of latitude as well as change of longitude. Between A and G, let's calculate. A is on 15 degrees north, B is on 30 degrees north. So 15 degrees north is the change of latitude. A is on prime meridian, G is 40 degrees east. So change of longitude will be 40 degrees. Between X and G, change of latitude will be 15 degrees. X is 15 north, B 30 north, B and G both. And change of longitude will be 20 degrees. So if both the places are in the same hemisphere, find the difference. And if both the places are in opposite hemispheres, one is north, other is south, or one is east, other is west, then add them up. Add the longitude of place X to longitude of Y and latitude of A to latitude X to the latitude of Y, and you will get the change of latitude and longitude. We will do some more numericals in our next slide. The maximum latitude of a place can be 90 degrees north, or here 90 degrees south, that is the South Pole. Whereas maximum longitude of a place can be 180 degrees. 180 degrees east, you will reach the anti-meridian, or 180 degrees west, and you will reach the, again, anti-meridian. 180 east and west is called anti-meridian of the prime meridian or the Greenwich meridian. And this anti-meridian of the Greenwich meridian, suitably modified, is also called international date line. That theory we will study in the theory lessons. We will do a few numericals based on that. Remembering the summary is both places in the same hemisphere, find out the difference, and places in the different hemispheres, add them up. And that will be your change of latitude or the change of longitude. Now, maximum change of latitude can be 180 degrees, that is from the North Pole to the South Pole. North to South Pole, dlat will be south. South Pole to North Pole, dlat will be north. What about the maximum change of longitude? Maximum longitude can be 180 east or 180 west. So if place A is in east meridian, B is in the western meridians, then how do we find out the longitude X if it exceeds 180 degrees? Up to 80 degrees, yes. Let's say one place is this side here, 89 degrees west. One is this side here, 89 degrees east. 89 plus 89 is 178. This will be the dlong west, and this will be the dlong east, towards east. What when it exceeds 180 degrees? What do we do to find out the change of latitude and longitude? Now I need a little bit of time to prepare the next slide. Let me first rub off this particular whiteboard and prepare a fresh board for you. The best way to prepare for your numericals, as per my practical experience, is sit down with one or two of your friends. Too many will possibly make it dilute the effort. But if you sit with one or two of your friends and then do the numericals, compare with each other, that will be an easier method of doing these numericals. Then you can compare with each other and also find out the difference. Okay. Next is, now, what if your longitude, change in longitude exceeds 180 degrees? Now let's draw a different diagram. And here, just a second. We will, in this diagram, see the diagram from the North Pole. North Pole is in the center. You are seeing it from the top. Then these will be the parallels of latitudes when you see it from the top of the North Pole. And these will be then the meridians. North Pole is in the middle, or the South Pole. For this diagram, I have taken the North Pole. If this is the North Pole, then this will be the equator, outer circle, 10 degrees north, 20, 30, 40, 60, 80, 90 north. Let's say this is your anti-meridian and this is your prime meridian. Then this will be 90 east, 180 east and west. That is your anti-meridian. And this will be 90 degrees west meridian. These are the longitude meridians east, and these are the meridians west. Let's say 30 west, 60 west, 70 west, 90 west. Then this will be the change of longitude. Between 90 east and 90 west, there will be 180 degrees change of longitude. If you have, this is place A and this is place B, change of longitude is west. If this is A and this is B, then the change of longitude is 180 degrees east between these two places, let us say. One is on 90 east, one is on 90 west. Now, what if one place is 130 east and other place is 150 west? Now, since they are in the different hemispheres, like we said before, we will add them up. place A is 130 east and place B in this case is 150 west. So from A to B, change of longitude will be 280 degrees west. Now, since it's more than 180 degrees, now we have to take a shorter arc, smaller arc to find out the change of longitude, and that will be this arc. That is 360 minus longitude of A plus longitude of B, and our answer is 80 degrees. We will say dlong between A and B is 180. Here, the difference that you can do is, here A is east and B is west. So your 280, our earlier answer was 280 west, but now answer will be 80 degrees east. Now let me show it to you. If this is place A, then this is the north. And this direction, 90 degrees to the right, is east. Now you are crossing the anti-meridian, 130 east, 180 east. After 50 degrees, you will cross the anti-meridian. And now this is your north, remember? So this is again east. This is north. This direction remains east. So 50 degrees and another 30 degrees, 180 to 150 west. So your total change of longitude will be now between A and B will be 80 degrees east. Between A and B will be 80 degrees east, and between B and A, it will be 80 degrees west. Add them up. Destination is west. Annotate it as west. But if it is more than 180 degrees, then 360 minus this sum, that a balance is your change of longitude. So between these two places, the change of longitude will be 80 degrees. And if this was west, your now answer will be east. These are some of the questions where people tend to make mistakes. So add, since they are in two hemispheres, add them up. If your destination, second place is west, write on west, second place is east, write on east. But when you subtract, after that, change this annotation, and you will get your correct answer. And let us see now change of latitude when you are crossing over the pole. Here, in that case, how do we sort it out? This is the North Pole. Let's say this is your meridian. And you are starting from 70 degrees north. That is your parallel of latitude, 70 degrees north. And your destination is on your anti-meridian, again 70 degrees north. Now your change of latitude will be 20 degrees north and further 20 degrees south. So total change of latitude will be 40 degrees. You will go over the pole. If you are going to 50 degrees north, then A to North Pole, 20 degrees. From here to 50 degrees north will be 40 degrees. And then now your change of latitude will be 60 degrees. And here we don't give annotation north or south because you are changing the direction. over the pole, once you cross over the pole. Now, this is the way in which we solve these numericals. And there are many more, and some numericals more on this. I will cover in the next lesson. And I don't want to burden you with too much of material in one single day. Slow and steady, but study every day and keep revising previous lessons. If you have done it once, it is not good enough. Keep revising them again and again, and the success will kiss your feet. Not to worry. Success always chases those who put in effort. Mind my words, and I mean it. Good luck, all the best. This is SK Booty signing off. And don't forget to share with your friends and like my video. Very fine. Don't forget to like and subscribe to my videos and continue with me till the time you feel like. Welcome, all the best, and those of you who succeed, don't forget to inform me and give me that little bit of happiness that I could contribute, even if it's a minuscule contribution to your success. It shall be a great pleasure for me. Okay, bye-bye, all the best.